Assalamu alaikum wa rahmatullah. Welcome everyone. Quality control. Today we will continue chapter 15 and we'll have extra examples for practical work for sampling acceptance. We will interpret the results and we will see how we do find the operating curve using the Minitab. Have your Minitab please next to you, that we will use it during this session. We will start with a quick review about the main terms and terminologies for this chapter. They are very important and we are going to use them and interpret them with numbers when we come to the example. So let's just have a quick review for those terms. The AQL, which is the acceptance quality level, that's mean the percentage of the defects that the customer is willing to accept and consider them as a good. So it is a percentage of defects, not the probability of acceptance or the percentage of acceptance, is the percentage of the defects that the consumer can accept it. The RQL is the opposite, which is the maximum defect rate or the maximum percentage of defect that is acceptable to the customer or to the consumer, and they also call it the rejectable quality level. So the percentage of defects that is accepted and the percentage of defects is rejected is the RQL. The lot tolerance, which is the LTDP, means the defect rate that will be rejected 90% of the time. Also, we can refer that is the percent of defect the plan also will reject 90% of the time. That means the factory will reject it 90% of the time based on the defect rate as the LTDP. The most two common used is the AQL and the RQL. From those two here, the AQL and the RQL, we will get the consumer and also we will get the producer. The consumer risk, which is the probability of lot, will contain defects exceeding than the LTDP, and it's going to be accepted. So in other words, the consumer will suffer if this happens because it will accept lots that has unacceptable quality level because it is exceeding the number of defects. And on the producer risk, the probability of lot that has a good quality but it will be rejected. So who's going to suffer from that is the producer. He is the one who's going to supply you with the goods or equipments or items or products. His lot it will be rejected even though he has a good quality, and the consumer is the opposite. It is driven from the AQL. That's mean you have accepted lot that has more than the acceptable defect rate. Those refer as beta and alpha respectively, beta for the consumer and alpha for the producer, and those they will be commonly used as a given information. That is, you have to interpret what does it mean when we come to the number of lots and number of samples that used. The last terminology is the AOQ, and that's mean the average quality level leaving the inspection point after rejection and acceptance of number of lots. That's mean you have done the acceptance and rejection, you have done your inspection. What is the average quality level? Average quality, not the maximum or the minimum. That's mean you may accept sometimes something that has number of defects close to the limit, sometimes is less than the limit. So what is the average quality in overall after you finish the inspection? And we refer to that as AOQ. Let's see, the examples will make things more clearer and more make sense to you after you see the examples. Let's start with this example here, two examples we have here. He gave you AQL. That's why you need to memorize those terms and understand them very well when you answer the questions. He gave you the AQL, which is the acceptance quality level, the percentage of defects that is acceptable for the consumer. He gave you the AQL as a 1.5% for a shipment of microchips, and alpha is 0.05. What does it mean? So he gave you the the producer probability, and also give you the AQL. What does that mean? When a question like that comes to you, you always refer to the definition of each of those terms. The term of the AQL means the percentage of defect that is acceptable, and the alpha is the percentage or the probability of the lot that contain acceptable quality will be rejected, and that is, we refer to it as the producer risk. So how we interpret this question? We interpret it by saying, right here, we will write this means approximately 95% of the time you will correctly accept a lot with a defect 1.5 or less. This is the 95 refer to 1 minus alpha for the accepting the lot with the maximum defect rate. So the maximum or the agreement defect rate, which is the AQL, is 1.5. He said that the consumer, he is going to accept a defect rate of 1.5 of the lot. So you have 1.5% of defect in the lot that is acceptable. So the percentage here, when we have 1 minus alpha, we will get the acceptable or the percentage of accepting, how it will be the confidence in terms of the acceptance. It will be 95% of the time you will have a correct acceptance of a lot with a defect that is equal to 1.5 or less. That's mean equal to the AQL or less. On the other word, we can have this also interpret on the opposite side, based on the producer point of view. We can say 5% of the time you will incorrectly reject the lot with a defect of 1.5 or less. Why we say that? In this time, why we said it is 5%? Because the 5% refer to the producer risk, which is the alpha. When we have 1 minus alpha, we will get the opposite, which is the acceptable of the lot based on the maximum defect rate or defective rate we have. The maximum defective rate or the acceptable defective rate was given as a 1.5% of defective in the lot is acceptable for the consumer. And the alpha is referred to the producer. The producer definition or the producer risk definition is the probability of rejecting a lot that has acceptable quality. What is the acceptable quality in that example? Is the 1.5 here. The AQL was given as a 1.5%. So the producer risk, you reject a lot or a patch that contain 1.5 or less. And that's referred to alpha, which is 0.05. That's why we say here in this question or this example, 95% of the time you will accept it with the 1.5 or less, or you can say 5% of the time you will reject it with 1.5 or less. Again, I will type it here. Remove the typing whenever we go back in the slide, so I will type it again. So it will be 95 of the time you will have a correct acceptance based on the defective rate you have, which is 1.5 or less. Or on the other hand, you can have 5% of the time incorrect. Incorrect, that's mean while it is 1.5% defective rate you have or less. The 5%, this is something going to harm the producer. Why? He has a good quality level that based on your agreement, which is the 1.5% of defective. However, this is a probability of the producer risk, which is the 5% of the time. But 95% of the time, it will be correctly accepted, okay? This is how we can interpret it in different point of view. So when it asks you, what does that mean? Or interpret the terminologies or the values you have, you can interpret it based on the given information from different two point of view. Either the producer probability of risk, or 1 minus the probability of the producer risk, which is the 95%. Okay, so this is like the positive side of that percent, and this is the negative side of the percent. For the second example, when we have received a shipment of goods that has RQL is 6.5% for a shipment items and beta equals to 0.1. What does that mean? Again, for the same thing, we go to the definition and understand what is the definition. The RQL is the number of defect that is where you reject the patch. So it is the maximum defect rate, and that is the acceptable to be shipped. So if you exceed this RQL, that's mean your shipment will be rejected, and he gave you that as a percentage of 6.5 and gave you the beta, which is the consumer risk, as a 0.1. The consumer risk give you as a 0.1. What does that mean? We also can interpret this information in two ways or in two sides, on the positive side of the acceptance or the negative side of the rejection. The positive side of the acceptance says 90% of the time, the negative side of the, because this is a consumer point of view, the 90% of the time, you will reject the lot with a defective rate 6.5 or more. So if you have 6.5% of defect or more, 90% of the time you will reject it. It is a positive point of view to the consumer, but it is also for the producer considered to be as a negative news or negative side. So the same thing, we can read it in other way, which is the beta value. not the 1 minus beta value, we can say 10% of the time you will accept the lot with a defective rate is exceeding the RQL. And this is going to be on a negative point of view or negative news to the consumer when this happens. That's mean 10% of the time at most, you accept a lot that exceeding the RQL. The RQL, when you set it, that's mean is the rejectable or the threshold, we can say is the threshold for rejection. That's mean if you have achieved it or exceeded, you have to reject the lot. And 90% of the time here you will reject it when this happens. But also 10% of the time you will accept it when this happens. Why? This happens in two ways or two sides, because the probability, it's a chance of occurrence. As well, there is a chance of occurrence of accepting, there is a chance of occurrence you may rejecting. You may ask, okay, why we don't have a 100% of the time rejecting the defect rate of 6.5% or more? This is a common question or a logical question. Why we don't have that? Since you are making samples, you cannot have 100%. Otherwise, you have to check all the items to say, I am going to work on 100%. As soon you decide to make samples, that means you are not inspecting all the items. So there is a chance of error when a probability of acceptance will have also a probability of rejecting. Or we can say a probability of accepting defect, there is also a chance of 1 minus that probability to give you another point of view or another side of the probability, which is the rejecting or accepting items that has exceed the percentage of defect you have set. And that's why we don't have a 100% probability, since we are doing samples. We have talked before about the samples, and some ask, okay, how we can really get the sample size in the lot? What is the exact sample size? We have talked about that. This cannot be just determined in a simple equation or in one or a straightforward method. Actually based on, as we say, the technique you are using for the inspection. What are the inspection costs? Because sometimes the inspection cost is very high. It is hard to maintain the testing cost for the factory. So the factory would really spend too much money in doing the inspection. And that's really reflect, as you can see, maybe on some products. When those products are highly tested and highly reliable, that will also reflect on their price, because the price is not about only the building that equipment or design it and produce it. It is considering also costs of inspection or cost of testing, safety tests, destruction of the item test to make sure the durability level and reliability. Therefore, the sampling size number is not just a straightforward formula or equation. There are techniques. I will show you today some techniques, and it is not based on the textbook material. Since the formula is given in the textbook material, which is the, I will show it to you here in the slides. This is the probability of acceptance formula, and it contains the sample size, which is the n factorial, and the number of defective you have set, and also as well as you set the probability for accepting, the AQL and RQL for rejecting. But to solve such formula and find the number of samples and number of defective, that where you make the decision in the sample that you accepted or rejected based on the sample size, not based on the lot size, you have to solve this equation or these two equations non-linearly. And non-linear is not something feasible to do it on hand, as you have learned in the operations research too, where you cover the non-linear. Also, there are some methods for calculating the number of sample size based on the specification or based on the confidence interval. And I will show you also those. There is websites do calculating the sample size based on the confidence interval. But let's start with this one here first. Solving two equations like this, when you have the probability of the consumer and the probability of the producer risk, solving these two equations in terms of the number of sample or the sample size number and the number of defective or the number of defective that where you make the decision to reject the sample or to reject the lot, we can do that in Minitab. We cannot do it on hand, but we can do it on Minitab in a way that he can solve those two equations non-linearly and give you the solution. So this is one of the technique you can have mastered in this chapter, even though is not related or is not based on the mathematical formulation where you can do it on hand. You need to learn software application to identify the result. Let's take an example, and I will show you how we can get the sample size and the acceptance number in the sample. We will have an example similar somehow to the previous examples that we have covered regarding to the AQ, the AQL and the RQL. Imagine or assume there is assembly managers hearing about a problem of one of your suppliers of capacitors. You order these components in a patch of 1,000. So the patch size or the lot size is 1,000 unit, and it is just not feasible to inspect every individual item coming. Is not feasible. That's mean even is not logical to inspect 1,000 unit, and it is just not also feasible. Not feasible. Sometimes, as we said, not regarding to the lot size number. It could be maybe 200 or 500 or 300 items. But the cost of the inspection is very high. So this is, as we said, it is going to be based on the consumer about making the sampling. But let's assume here is not about identifying the cost limit, is about to find a sample size is acceptable to this consumer in terms of the cost. That's why we are not going to discuss the cost here. And he wants to find whether to accept or reject this lot based on a sampling. So he wants to use sampling so you can make the decision about accepting or rejecting, or how I can make the sampling in a way that I can make the decision about accepting or sampling. He asks you here to create the sampling plan for the acceptance. Means he wants you to find how can I make the correct sample and identify when I accept the sample and that lot based on the found number of defects. He agreed with the supplier. So the consumer and the supplier agreed to have AQL as a 1% and the RQL as a 8%, and the producer risk will be 5%, and the consumer risk will be 10%. So those values given to you with the number of batch and ask you to find the sampling plan. The most important things or findings need to be found in ask you about the sampling plan is finding the operating curve and finding the sampling plan that where you will accept. The operating curve, even if you don't have the sampling plan, it will give you an overview about what is the relation of the number of defective that you have found or you may found in the lot versus the probability of acceptance. So if the percentage or the number of defective, you can refer to it based on the question. In the question here, he gave it to you as a percentage. He could give you the AQL and the RQL as a number of defective per million. Since it is a percentage, so he gave you the percentage of accepting and rejecting. And you can have that in the operating curve versus or demonstrated visually versus the number of defective and the probability of acceptance, which also will help you to identify how you will accept the lot or you will reject it. And the second findings that you can do it on the Minitab, which is the number of sample size or the sample size n, and the number of defects or defective that is based on the RQL, where if it's exceeded, then you have to reject, and if it is below, then you can accept the patch. The findings from the Minitab, it will be based or it will be demonstrated as you can see. We will see later after the explanation of the results how we can conduct this on the Minitab. As you can see here, this is the second part of the finding. It gives you the sample size, which is the 65, and the acceptance number is 2 defective. The interpretation of this one, for this 1000 capacitor that you have going to receive it for inspection, that is the lot size you have, you need to randomly select and inspect 65 items or capacitors. And if you have found 2 defectives, more than 2 defectives, because we are dealing with the RQL, more than 2 defectives, that means you should reject the entire lot. You should reject the entire lot. Or if you are going to do double sampling, then you have to do as what we said about the previous session. You have to collect all the defectives in the samples, and then you decide whether to go accept or reject. But assuming with the given sample, single sampling, you can decide about the acceptance number is 2. That means if you are exceeding the 2 defectives in the sample size 65, you will reject the whole lot. And the other part which is needed to be found in the analysis for the operating curve or the operating characteristic curve is this figure here. This figure, it shows you the probability of acceptance versus the percent of defective in the lot. When we zoom in, it will come to this figure here. You can do in the Minitab pressing on the lines and gives you all the values or all the points on the probability acceptance curve versus the of defectives. That values we will demonstrate it later in the Minitab, so you have a better view and to see the results, how it look like. This curve, it is important in the way how you will deal with the percent of defective versus the probability how I'm going to accept this lot based on the founding percent of defectives. The results here in this table represent the probability of acceptance here, which is based on the vertical side or the y-axis in the chart, is given as 0.972% or probability of the time. You can say 97% of the time you will accept the lot when you have 1% of defective. And where we got that 1% of defective, we got that 1% from the AQL that is given as agreement between the supplier and the producer. And you will have 0.099 probability, which is almost 1% or 10% of the time you are going to accept when you have a defective percent is 8. And where did we get the 8 is the RQL, because the RQL is the rejecting quality level and it is 8%. So if you are going to exceed the 8%, that is mean the lot will be rejected. But if you are 8 or less, that's mean you are going to accept it. So the one here, the one defective you have is referring to the AQL, and the 8 is referring to the RQL. And that is the probability of acceptance at the AQL and at the RQL. Between those two values, or even exceeding the values here of the defective percent, the lot will show you what is the probability of acceptance. So the probability of acceptance plot here, it will show you when the percent of defect, whether it is achieving or exceeding the AQL or the RQL. The probability of rejecting column here is 1 minus the value of the probability of acceptance. So if it is 0.972, 1 minus 0.972, it gives you 0.028, and 1 minus 0.099, it will be 0.901. The average outgoing quality after the inspection, when you work at the, or you have a percentage defective 1%, it is going to be 0.9. And if you have going to have a percent defective at 8%, you will have average outgoing quality after inspection 0.74 or 74%. how we do these charts, or how we do these tests on the Minitab, we will share the screen now, and we will demonstrate how we do it. First, let's take the question. There was someone to have a question here. Do you have a question before we open the Minitab? Okay, so when we would like to do the analysis on the Minitab, we go to Stat, and we select Quality Tools, and we select the acceptance sampling by attributes, and then we enter the information that is given on the question. In our question, we will use creating sampling plan because we don't have the readings. We want to create it, and we want to find the sampling plan in our case, and we will select the defective because those are the decision-making criteria, is to accept or reject. And then we have a percent of defect, which was the AQL was 1 and the RQL was 8. And then we have the producer risk, which is the alpha, and that was 0.05, and the consumer, which was the beta, which is 0.1, and the lot size was 1000. When you press the OK, then the result will come to you here on this area, where you can have the values of the sample size is 65 and the acceptance number is 2, and all the values here are, you can save those as a picture, you can print them, you can copy them in your document. So in the exam, when you need to upload your results, you can have all these results. If you would like to upload your Word document, the figures here, when you double click on the figure, it will enlarge it. And then how you get the values in the curve, you just press on the curve, so all the values will appear to you. So if it asks you in the question, what is the probability of acceptance when you have defective percent as percent? So if I have a 6% of defective, what is going to be the probability of acceptance? So when you open here, you will see on this side, on the left side of the lot of percent defective, when you read the value of 6, the probability of acceptance be 0.244115. So the probability of accepting the lot when I have a percent of defective is equal to 6, it will be 0.244. When you compare that to the AQL, definitely that is exceeding the AQL because the percent of the AQL is 1. The AQL, when it is 1, which is 1% defective, you can see the value of 0.4% of defective on the left column, and 1.2% of defective also on the left column. That is associating with 0.997 of probability of acceptance when the percentage of defect is 0.4 and 0.95 when the percent of defective is 1.2. So if I want to find the probability of acceptance when the percent of defective is equal to 1, I have to do interpolation because the value is not given here, but I have values before and after the lot percent of defective, because the lot percent defective that is set or accepted by the consumer, which is the AQL, it is 1, and the 1 is fall between 0.4 and 1.2. To find them, you can do the interpolation. When you do the interpolation, you will have a value of probability of acceptance between 0.99 and 0.95. And that is the value of the probability of accepting at the AQL, which is given here or found here. You can see it in the blue column where is the pointer. It says the probability of acceptance in the table. You can see 0.972 is when the AQL is 1. So you will have probability of acceptance 0.97 or 97% of the time you will accept the lot when you have percent of defective equal to 1. So any value of defective is here, you can find it from, or you can find the probability of acceptance from this table or from this figure. That's why this is the sampling plan that helps you how is the probability of accepting for the given percent of defective found in the lot. And the second part, which is the important part, is the sample size that you are going to do and the number of defective that is acceptable, because if you are exceeding even the Minitab here, it gives you that information. Accept lot if defective items in 65 sampled less or equal to 2. Otherwise, you reject that lot, and all the values that you enter to verify them, it is summarized in this table. So this is how we do the analysis using the Minitab. Let's take another example and see another requirement and see how we will interpret also the values that we have covered in the terminology slide. This is another example. This example let's read the example now and see. The manufacturing engineer receives weekly shipments of 2-inch plastic pipe and segments for an assembly process. This is used for assembly process. So this is a part that they use it for assembling process. The lot size or the part size is 2,500 plastic pipe. The engineer decides to implement a sampling plan to verify the pipe wall thickness. So he wants to make sure the thickness of those pipes are within the acceptable range he has. The lower specification here given for the pipe wall thickness is 0.09 inch. The engineer and the supplier agree that the AQL is 100 defective per million and the RQL is 300 defective per million. He asks you to create the sampling plan for the acceptance. Ask you if you have the incoming lot defectives per million is 64, what will be the average outgoing quality? So he asks you two things. You have to find or create the sampling plan. What will be the sample? You have to find or analyze the operating characteristic curve, and also ask you specifically if I have incoming lot that has defectives per million is 64. What is the average outgoing quality will be? In this question also, we will do the same analysis using the Minitab for the two reasons. First, you cannot plot this graph using manual or hand solution. The sample size cannot be found as linearly or manually calculated. The Minitab in this way will help us to identify the sample size as well as to decide about such case like that. If I have a certain number of defectives, what will be the average outgoing quality, or what will be the probability of acceptance? It could be either of these type of questions. Let's see the results. The results will be similar or will look the same as have explained previously. The difference here, it is asking about the average outgoing quality, which is this figure here, AOQ curve, and he wants you to find the AOQ, the average outgoing quality, when there is 64 defective per million. See, so you have the incoming lot defective per million. I have 64 placed horizontally here. So what will be the average outgoing quality? It will be something close to the 20% or 20 items that will be considered to be the average outgoing quality. Hold on, let's, yes, the sample size here, it is found. Yeah, I wanted to check that. Did we calculate the sample size? Yes. So the sample size, it is the main part you have to identify in order to can elaborate or interpret the values here. How can I say the 62 defective or the 64 defective, what is the average outgoing quality if I don't have already identified the operating curve and the sample size? Let's do the results here first on the Minitab and see how we can explain the results here more. So let's open the Minitab and try to enter those values and see how the average outgoing quality it will look like. It is not visible here, but is the chart here. It has the values when you have a defective rate is 64. So it is around 44 defective per million will be the average outgoing quality. Since the values here is not percentage, we have to pay attention when we do the input in doing the operating curve. We have to use the defective rate, not the percentage. If you recall the previous example, the value of the AQL was given as a percent. So here, even the value of the average outgoing quality will be a number of, in the first example will be a percent, but in the Second example, it will be a number of defectives, because he didn't give us the input as a percentage. He gave us as a number of defectives. And when we have such case, we have to pay attention when we put the entry for the values in the Minitab. So we have the AQL given as a 100 and the RQL as 300 defectives per million. The consumer risk and the producer risk will be used same values, 0.05 and 10% for the consumer and 0.05 for the producer, since is not good, it was not given. And those are, as we said in the previous lecture, that the most common use values for those parameters. But the new thing that we have here, we have the lower specification for the pipe thickness. It's given 0.09. And usually when you are going to work with the number of defectives, you will need what is the lower specification that you have. Sometimes they give you the lower and the upper. In this case, since only the lower it was the given, so we can use only the given information that we have, which is the 0.09. And since the upper it was not given, so we don't have to worry about that. So let's do the Minitab and try to see how this will be look like on the Minitab, and then we go back and interpret the results. Okay, so we go to the same thing, stat, and then quality tools, and then we go to the acceptance sampling by attribute. Here, when it opens, first we have to find the sampling plan as it is requested in the question. But here you have to pay attention that you are not going to use the percent defectives, because the defective was given to you as a number or counts. So we have to use defective per million. So you have to change the tab into defectives per million. And then you enter the data that was given to you based on the lower or the AQL and the RQL. So let's have the slides. Okay, I needed the value, that's why I had to open it here again. So the defective per million will be 100 for the AQL. This is the acceptable quality level. And for RQL is 300. For the producer and the consumer, we will not change the values. the lot size will be 2,500. This is the number of the lot size. And then when you press OK, okay, there is something here wrong in the. Let me double check that. I had the results before, maybe the entry. I think the lower specification, maybe I haven't entered the lower. So let's double check. Oh, okay, sorry. Now we don't go to the attributes. We have variable data. The thickness size, it's a variable data. So we go to the quality tools and we go to the variables, not the attribute, because the thickness is by inches and these are variable data, not a percentage of accepting defectives only. And we do the same, create sampling plan, but for the variables. So when we go here, it will be the same window. It looks identified from the top window here when you see the acceptance sampling by variable. So you have to identify whether you are using the attribute or the variable. The attribute, we use it when we have attribute information like the previous one. We have a percentage of defectives. We didn't have a specification that is related to a variable data, but we have a pipe thickness, and the pipe thickness is variable data. So we go only to the variable window, and it will look the same, but here you will have the lower specification given or needed to be entered. So we start entering the information again is 100 for the AQL and 300 for the RQL. The producer and the consumer will be the same. We have to do the lower specification as 0.09. Pay attention to use the defective per million if the question gave you the defective in that format. If it gave you the defective as a percent, but gave you a specification with a variable data, then you have to enter the variables, not the attribute, and you enter the lower specification here. If there is upper specification given, you have, then you enter it. If you don't have, it is okay. As well as if there is standard deviation for the previous historical data. The lot size we have in our case is 2,500. Now it should work. Yes, now it is working. Then we go to find first what is going to be the sample size that you are going to collect randomly among the 2,500 lot. You collect 760 items as a sample, and you make the decision based on a value here called the critical distance. We will talk about that. What is the critical distance? It is a z-value, the z-value that you use or you find from the table. We will explain it, but you don't have to mathematically find it or using the tables. The Minitab, as for the sample size, he does it for the nonlinear equation calculated. He will calculate the critical distance for you. That means you accept the lot if the z-value is greater than the lower specification limit. And we will have an example only explain about the value for the critical distance. But here, let's answer the questions that in the in this example. This example focused on the AAQ curve, which is the average outgoing quality, and ask you to find what will be the value that when we have a 64 defect per million. When you you press on the curve, this window will open and it will show you the relation between the incoming defective per million and the average outgoing quality. As we say, the average outgoing quality means the quality of the average quality after the inspection. So you have done the inspection, you accept, you reject. What will be the average outgoing quality? If the question or the example we had, it asked you about the 64 defective per million, then the 64 defective per million on the left column, it is associating with the 44 defective per million as average outgoing quality. Pay attention again. The parameters here, it was not percentage like in the previous examples. And that's why the interpretation here, it is going to be based on the number of quantity, not based on the percentage of quality or percentage of defectives. The defectives here found, or in the question asked you to find it at 64 defective per million. The quality, when you have 64 defective per million in the lot, the average outgoing quality, that means that will be processed after the inspection, it will be 44 defective per million. That is the average quality outgoing after the inspection. The operating curve, it will work the same as we did in the previous example. But here we have the lot defective per million versus the probability of acceptance again. So if I have 64 defective per million, I will have probability of acceptance 99% as a percent or 0.99 as a probability. This shows you the relation between the probability of acceptance and the number of defectives per million in the lot. Here it shows you the relation between the average outgoing quality that will be after the inspection, how many defectives, in this case, since there is a defective per million is the metric, versus the incoming defective per million. The incoming defective in the lot, if it was 64 defective per million, then I will have a 44 defective per million as an average outgoing quality. So here where you answer the question, the average outgoing quality when 64 defective per million found in the lot will equal to a 44 defect per million as an average outgoing quality. And if it asks you about average or probability of acceptance based on the defective per million opportunity or per million in the lot, we will do the same as we did in the previous example. We will use the operating curve, which is the operating characteristic curve versus the probability acceptance. And again, as we did previously, the AOQ, the acceptable quality, or AQL, sorry, the AQL, the accepting quality level, is 100 defective per million. What is the probability of acceptance when we have that level of defectives? It will be 0.95 or 95%. When we have the RQL, which is the rejecting quality level, is 300 defectives per million, we will have probability of acceptance, it will be 0.1, which is 10%. Okay? And the average outgoing quality at the AQL level or acceptable quality level, it will be 66 defective per million. And at the RQL, it will be 21 defective per million. And the sample size, we said 760. The decision criteria about accepting or rejecting, it will be based on the critical distance or K value. And if that K value is exceeding the, if the Z value is exceeding the specification then we reject it. We will see another example about this criteria that is different than the sample size and the number of defective in the sample size, because this is going here differently. We have variable data, not a continuous, not attribute data. And when we deal with the variable data, the specification of the dimensions will matter, and that's why the criteria for making the decisions will be different. The third example, or the fifth example we will have, is going to show us okay. For this example, I will leave this to you to practice it on Minitab. Is going to be based on or similar to the example we covered here. It is similar to this, no, not this example, to this example, the capacitor examples, okay? It is similar to this one. I want you to practice it without looking to the solution, okay? It will help you to practice and answer questions based on the given information about the AQL or the rejecting quality level and a sample size given, okay? So practice this example at home and try to solve it. Then I will upload the solution after you try it. And today I want you to explain this example, which is going to have a variable data. At the same time, you are going to be asked whether to accept or reject. We said in the attribute data, it is going to be easier because the Minitab will give you directly the criteria, the sample size, and the number of defectives. If it is found, then it is going to be accepted or rejected. On the variable data gives you the decision criteria, but you still don't know how I accept or reject when I have a sample size. How can I put it into test based on that constant, the K value? In this example, we will try to practice it also on the Minitab using the given data here for the thickness of the part that is received in the shipment, which is 3,000 lenses, and then you have selected a sample, or you have taken a sample of 259 of those lenses to measure the thickness, and you have lower specification and specification. And wants you to say or decide whether I accept or reject. So this is a different concept on accepting and rejecting. I have a sample size, but I don't have AQL and RQL. I have specifications. I believe the time, I think it's running, so I will stop here and I will continue this example on the next session. Please, during this time, try to practice this example here. It is similar to the previous examples we have covered. Try to do it your home. Try to find the results from the Minitab and explain those results, interpret them, answer the question, and we will continue with the example on the next session. So I will stop the recording here.